or 30?
Yeah, 30 seconds.
Oh, okay. Good day, and welcome to Africa Teen Geeks Online School. My name is Nonkulilego Matondo, and if you are in this class, you are in your Physical Sciences Grade 11 class. I hope that everybody is in the correct place and is ready to get fed, with all the stuff that we're going to be doing today. If you guys remember quite properly, yes, last week on Friday, we started the revision for chapter 5. We did the first part of our revision, but we did not finish, and we're going to be finishing the revision of chapter 5 today. Guys, if you guys have just joined in, I just want to let you know that we're working here from the Oxford Successful textbook. Yes, the Oxford Successful textbook. So if you do have that textbook, then that's great. So today we're doing the revision for chapter 12. But if you don't, you can always get it from Snaplify. Snaplify, it's an app that you can get on your Google Play, and you can register there and you can get every textbook that you're looking for online. It's absolutely free up until December. So the free subscription lasts until December, so you can get all your textbook. So why do we use Oxford Successful Textbook? Because we refraining from using too many textbook that will end up confusing the chapters and we won't be able to follow through what we are doing. So yes, I am Nonkulego Madondo, and you guys are in the right place. We're going to be doing some revision today, and I just want to let you know that you can also get me on LinkedIn as Chio Matondo if you guys want to, ask some more questions. But nonetheless, here, you guys can send me a chat whenever I'm explaining and you get stuck somewhere. Just let me know, send a shout out, and I'll make sure that I explain thoroughly what you guys are having problem with. What I like about this revision that we're doing is that we are doing calculations, we are doing problems of everything that we have done in the past 2 weeks, and we are closing down chapter 5. We will be continuing, however, with chemistry chapter 7. So don't worry, we're just going to be doing chemistry and then we'll do electricity after we do chemistry, so you guys don't have to worry about that. So we're just going to go through everything 1 unit a day. We're trying to make sure that you guys understand, because the most important part here is for you guys to understand the syllabus. It's not about just completing the syllabus, but for you guys to make sure that you guys understand each and every unit, not even chapter, each and every unit that has been done. So I hope that this will be very productive for you guys. So getting back to the problems that we've been working from since on Friday we started with our revision questions. I just want to share one of our problems. Yes, let me go on Snaplify. Okay, guys, I hope that you guys have done your problems. If you remember properly, on part 1, we said that we would do the odd numbers on the first part, but on this second part, which is what we were about to start when our time ended last week, we said that we would do the even numbers. So we're going to do 2, 4, 6, 8, and 10. Okay, so I hope that you guys have tried doing these problems on your own, just to make sure you know that you guys are getting into understanding where you're getting stuck, where you're lacking, where you need more help. And that's why I always give you guys homework, to make sure that you guys keep testing yourself. Unfortunately, I can't be there with you to check your homework, but I hope that you guys can check your homework by doing your corrections and asking where you guys get stuck. Okay, so we're going to start with number 2. We're still on stoichiometric calculations with concentrations, limiting reagents, and percentage yield. Yes, these things, once you get used to them, they become simple. But the aim is for you to get used to them so that they get programmed in your mind through practice. Okay. So it says on number 2, a fuel mixture used in the early days of rocketry is composed of two liquids, which is hydrazine N2H4 and dinitrogen tetraoxide, which is N2O4, which ignite on contact to form nitrogen gas and water vapor. Okay, so what they give us here is that 100 gram of N2H4 reacts with 200 gram of N2O4 according to the reaction. Okay, so what do we know? Already now we know we've been given two masses. Immediately your mind must just go, okay, two masses, it means that we need to find our limiting reagent. Before you even read the question, you should be able to know that, okay, if they give me two masses and it's two substances that react with each other, it means that I need to find my limiting reagent, okay? And make sure, guys, before you even look for that, make sure that your equation is balanced, but they usually tell you when it's not balanced. So in this case, you can see that it's balanced. But if it's not, you have to make sure you balance it. Otherwise, everything that you're going to write is going to be wrong. Okay. So let's go to the answers quickly. I think that I'll try and read it from my phone. I'll try and read it from my phone just to make sure that we don't get lost. I mean, keep going back and forth with the questions. We'll probably just come back when we're doing the next question. But for now, I want us to, I'll just reiterate the questions on my phone. Okay. So here we are. What are we looking for? We're looking for our limiting reagent. So what is important here? When you look for the limiting reagent, you just focus on your reactant. So you must always think limiting reagent, which means it's this part, it's the reaction side of your equation. So you've got 100 gram there and we've got 200 gram there. So we need to find, using these two, we need to find our limiting reagent, okay? So first we're going to start with this one. Usually it's also good if you can maybe write them on opposite sides. Like for example, you write this one this side and this one that side. But the problem with that, it's sometimes you get that your molar masses, it's a long substance and it needs more space to it. Like for this one, for example, as you can see here, it says, okay, we look for the molar masses. Remember, guys, molar masses is something that you guys always have to be able to find. Why is that? Because you've got a periodic table. Whether it's test exam, they'll always give you guys a periodic table so that you can be able to find your molar masses. They will not tell you, however, how to find it, but you guys just need to know that once you have it, you have to convert everything to the number of moles, and to do that, you need your molar mass. Okay, so there we have it, and our molar mass becomes 100 divided by 32.04516, and this is what we get at as our number of moles of N2H2. Okay, and then we do for the second one, which is going to be N202. Guys, please always write here your N2H2 of H2 so that you guys don't confuse, because sometimes it does get confusing, especially when you've done long questions. You tend to lose track of which what number of moles is this calculation, what number of moles is that calculation. So always write 3.120706 mole of N2H4. Okay, and then from there we move on to the next one. Remember, guys, right now we're still looking for the limiting reagent. We haven't started calculating what is needed, and you need the limiting reagent because that's what you're going to use to calculate your product. Okay, I just made the screen a bit smaller. I hope you guys can see. And don't forget, if you're getting lost anyway, just let me know on a chat. Then we find the molar mass of the second reactant. We've got two reactants. So this is the molar mass of the second reactant. After that, we're going to take the number of mole ratio of each. So we're going to be N of N2H4 divided by N of N2O4, okay? And what do we take there? We take these numbers here. Ooh, where have I gone to now? Okay. Yes, you take these ones here, which means for N2H4, you're going to take 2, and for N2O4, it's going to be a 1 because there's no number that's written, so we always assume it's a 1, okay? And then we ratio them against each other, so we divide them to get our baseline. So this is going to be our baseline that we're going to use to calculate our reagent. So what do we know about the baseline? What we know about the baseline is that if you calculate these two substances against each other with the actual number of moles, if the number that you get is going to be less than 2, then our limiting reagent is going to be N2H4. But if we get a number that's greater than 2, then our limiting reagent will be NO2O4, okay? So what do? We go straight to it and we calculate the number of moles against each other, and they're going to give us 1.4356. So this is less than the 2 that we have here. So what does that mean? It means that our limiting reagent will be N2H4 because it's less than 2. I hope you guys understand that part, but if you don't, just let me know and I'll reiterate it further, okay? Then, now that we have our limiting reagent, they're gonna look for. Okay, let me just go to the question because I can't locate it with my phone. Um, okay, so now we found our limiting reagent, which was the first question. So our second question is going to be calculate the mass of H2O vapor that is formed. So now that you've got our limiting reagent, it means that now we can calculate our product because we use the limiting reagent to calculate the product. So if your limiting reagent is wrong, it means everything else is going to be wrong too. Or maybe you might get marks for the volume of N2 because that one, it's totally independent of the limiting reagent. So that is very important that you make sure that your limiting reagent is correct. Okay. So for the first one, we're going to look for the mass of H2O that is formed, which means that we're basically looking for the product. And the second one, the third one, calculate the volume that is formed at STP. So what does that mean? It means that we basically looking for
Hi, everybody. Ma'am will be back in a moment. She just disconnected. She is going to be back just now. Just maybe give her a second. She'll be here with us again shortly. Hi, everybody. Like I said a moment ago, ma'am is having some technical difficulty. She will be back in a moment. Um, yes, so just maybe give us a minute or two to try and get her back on.
Hi, guys. My sincere apologies for having a bad connection. Thank you guys so much for your patience. And yes, we are back. Um, so we're still talking, going to number two, looking for the number of moles of the H2O that is formed. So what do we use for the number of H2O that is formed? We are going to use the limiting reagent which we have just found, and then we're going to equate them against each other, the ratios, like we always do with all our calculations. Take what is the limiting reagent, you equal it to what we are looking for, and what we are looking for is going to be the number of moles of N2H4, which is the 3.1206, divided by 2, which is the ratio of the number of N2H4 molecules that we have. And then we divide that, we equals that to the number of H2O divided by the ratio. And where do we get the ratio in this case? It's this number here. You see, I use the 4 because here there's 4. And for N2H4, we've got a 2, which is what I have right here. And then from there, now we've got the number of moles of H2O, which is 6.2412 mole of H2O. Always write it down to make sure you don't get confused in the later calculations. Therefore, now that we've got the number of moles of H2O, now we can look for the mass. And to find the mass, once again, we need the molar mass. Don't forget, guys, when you calculate H, you must times it by 2 because there's a 2 on the subnumeral, and you add it to the one that's next to it. And this is how we find our mass. And you write that it's going to be 112 gram, 0.44 gram of H2O, or you can write water. They basically mean the same thing. Okay. So the next one that they're looking for, I think they're looking for the Volumet Stp of the nitrogen gas. So what are we going to do first? First, we're going to find the molar mass of the nitrogen gas, and then we're going to have it right there. And then after that, we're going to do the moles ratio again. Remember the moles ratio? Basically, we're going to go straight to the moles ratio because um, we already have the N2H4 and we also have the ratio of N2H4. You see, guys, we're still using the limiting reagent. That's why the limiting reagent is so important, because you're using it to calculate everything with regards to the product that we are getting. Okay, so the N of N2 um, is what is unknown in this case. So you're going to take this and you're going to say 3.1206 times by 3 divided by 2, and this is the answer that you're going to get. So now we've got our moles of the nitrogen gas, and now we can go straight to our volume at STP that we are looking for, and that is going to be N times Vm, and it's going to give us 104.83 dm cube at it. You can also write of N2 at STP. Okay, I hope you guys are following. If you stuck, just shout out quickly and I'll go back and explain whatever you're having a problem with. Okay, so 2.4, 2.4, let me see what they're looking for on 2.4. Okay, on number 2.4, what they say is calculate the mass of the reactant in excess that remains unreacted. If you guys remember, on the limiting reagent, there is a problem like this that we dealt with in, I think, in the activity 3 that we had a problem like this that we dealt with. So I hope you guys didn't have too much of a problem getting this. So when you look for the mass of the reactant in excess, first of all, we need to know how much is in excess. Okay, so how do we know that? We need to know how much actually reacted with the N2H4. And then what we're going to do from there, we're going to take the original, which is the 200 gram, and we're going to minus how much reacted, and then that is going to be our answer of the reactant in excess. And how do we do that, guys? Okay, let's go quickly to our Okay, let's go quickly to our answer. But I hope you guys understand what I mean. To calculate the mass in reactant, first we need to find how much reacted, and then we can minus that with how much did not react. Okay, 2.2. Okay, let me go back to 2.2. It says they calculate the mass of the H2O vapor that forms. Okay, so what do we know about calculating the mass of H2O? H2O is a product, and we've got our two reactants on our left hand side. So for us to calculate H2O, we need to find our limiting reagent, which is what we calculated in 2.1. Everything that you're going to calculate on our product side, you're going to need your limiting reagent. So what do we do? What do we do is we're going to say the limiting reagent, the coefficient, which is going to be the N divided by ratio, and we're going to equate that to the H2O, which is going to be N of H2O divided by ratio of H2O. But what do we have in this case? Let me just go to our problem, our solution. Okay, number 2.2. Um, I'm just sorry, maybe it's because it's all mixed up that you can't see properly. Okay, so here we are. We're going to have the number of moles of N2H4 divided by the ratio of N2H4, and that will be equal to the number of what is asked for, which is H2O in this case. We're looking for H2O. So you use your limiting reagent to calculate anything in the product. And what are we going to have here? This N2H4, it's what we calculated in the beginning of our problem, which is here. Remember, when we were still looking for the limiting reagent, we calculated our number of moles, which is 3.1206, and then we come back and we say the ratio. The ratio, remember, it's a number in front of your compound. So if there's a number in front of your compound, in this case, we have a 2 in front of the N2H4. And for the H2O, we do not know what's the number of moles, but we do have the ratio because there's a number in front of the H2O. And even if there is no number, we assume it's a 1. In this case, we've got a 4, and that's why we have a 4 written here. Okay, and all of this, oh yeah, here it is. I'm sorry, this one, just ignore this. Go straight to the arrow. It's going to be 3.1206 divided by 2 is equals to NH2O divided by 4. And therefore, the number of moles, we're going to say 3.1206 times by 4 divided by 2, and that is going to give us 3.24 6.2412. I hope that you understand so far. If you're still a bit confused, just let me know and I'll go back to it again. And then after that, now that we have the number of moles of H2O, now we can go straight to finding the mass, because that's what they're looking for. They're looking for the mass of H2O. So we're going to look for the molar mass. Why are we dividing by 4? Okay, let me show you why we're dividing by 4. Remember what I said. When we have a ratio, we're going to have N divided by ratio of H2O. Okay, so in this case, we do not, okay, let me start with this side. Okay, on this side, it's going to be NH2H4 divided by ratio H2O4. Okay, so where do we get our number of moles? Our number of moles is what we calculated in the beginning, which is 3.1204. And then the ratio is the numbers here. When we check our balanced chemical equation, okay, when we look for the ratio, we look for the number in front of your compound. So for N2H4, we've got 2, and for H2O, we've got 4. So here, we already have the number of moles, hence we wrote the 3.1206 divided by ratio of this of N2H4 is 2. And then on the other side, for H2O, the number of moles of H2O we do not have, but we do have the ratio, which is a 4. So that is why we're dividing it by 4. I hope that you understand it now. And if you do, just send me a sharp head finger so that I can know that you get where we get that from, and we can continue from there. Okay, so basically the ratios are important. That's why I always ask you guys to always make sure that your equation is balanced. Okay, no, that's great. So we're moving on. Okay, number 2.2. Okay, so now you understand why we divided it by 4, because the ratio is a 4. Don't forget your ratios. Always make sure. That's why you need a balanced chemical equation, because when you balance a chemical equation, if it's unbalanced, the ratios is what you're going to be adding. in front. Actually, it's a number of moles, but I use ratio so that you guys can distinguish between the N and the ratio, because the N is actually an actual number that it's going to give you an answer in moles, and ratio is just the number in front, but it's also the number of moles of that compound. Okay, so I hope you get it now. And then moving on, so we looked for the molar mass, which is of H2O, and it gave us this. This is what you get on your periodic table. And then for the mass, then we take whatever we got on 2.2 on the number of moles times the molar mass, and that will give us 112.4 grams of water. Okay, so I hope that you guys get how we got to this one. Okay, and then for 2.3, I hope that you guys also understood it, because it seems we had already done it by looking for the number of moles ratio using the limiting reagent, equating it to the product that we are looking for. Okay, product compound that we're looking for, and this is what we got. So now we came to the excess, okay, which is what I was explaining. When you have excess, when they ask how much of the excess reactant is left behind, remember we've got a limiting reagent and we've got the reactant in excess. A limiting reagent is the one whereby when it's used up in the reaction, you can no longer proceed. So it's a maximum of the reaction, and that's why it is what we use when we calculate anything in the product, because it all depends on how much of the limiting reagent we have. But the reactant in excess, that's the one that's in abundance. There's too much of it, so it only, in a reaction, it only uses up as much as the limiting reagent needs, and what is left behind gets left behind. Okay, so now they want to know in this question, after the reaction was done, how much was left behind for the reaction in excess. Okay, and what we need to know about the reaction in excess, how do we calculate it? How do you calculate it? First, we need to know how much in the equation was used. Okay, so how are we going to find that? We're going to equate the reactants together. Okay, so this is our reactants here. Let me just go up to show you guys. These are our two reactants here. So if we look for the reaction in excess, there's only two that is going to be needed. There's only two that's going to be needed. So what are we going to do? We're going to equate these two against each other, and then after that we're going to find this one. This one is going to be our unknown. Okay, so let's go back, and I hope you guys understand. If you don't, please don't hesitate, just let me know and I'll explain it again. So here we're going to equate the reactants against each other to know how much, because the reaction equal amount of each were used. So N2H4 will be equal to N2O4. Okay, so this is what we're going to have. We're going to have our 3.1206 divided by 2, but we're looking for the reaction in excess. We want to know how many moles of the reaction in excess did we use in our equation, and we're going to divide that by 1, because our ratio in this case, there is no number on our N2O4, so we assume it's a 1, and this is what we're going to get. Okay, after that, now we've got our reaction, the amount of moles that we used in the reaction for our reactant in excess. Now we can look for the mass that was used in this reaction, and in this case it's going to be N times M, and it's going to be 143.55 gram. So which means in our reaction that we did, 143.55 gram out of the whole 200 gram that was given was used. Why? Because our N2H4 got used up, so the reaction couldn't continue anymore, so it stopped when this much was used. So now they want to know, what is the mass in excess, okay, of the reactant in excess. So we're going to say 200, which is what was given, and we're going to minus that with 143.55 gram, okay? And this is going to be our answer. I really hope you guys understand the reactant in excess, because they can be really tricky, especially if you are confused on how to get it. So I hope you guys understand that. Now, moving on. Let's go and see what do we have on our number 4. Okay, guys, reminding you, we are using the Oxford Successful textbook. So if you don't have one, you can just follow. You can even take screen grabs and just follow through the problems as we go along. Okay. So on number 4, it says, in a fermentation reaction, glucose is converted to alcohol and carbon dioxide. Calculate the following equation. Okay, let me check it on my phone. Okay, let me just have the reaction in question. Okay,